This is 12th mathematics, chapter 4, inverse of trigonometric function. Exercise 4.1, question number 3. Sketch the graph of y is equal to sin x by 3 for 0 less than equal to x less than equal to 6 pi. Now, on the right hand given function y is equal to sin 1 by 3 of x. Now, compare with y is equal to a sin dx. Therefore, a is equal to 1 and b is equal to 1 by 3. Now, we have to find out the amplitude. So, amplitude is nothing but the modulus of a. So, modulus of 1 is equal to 1. And next, we have to find out period. So, this is nothing but 2 pi divided by modulus of b. Here, b is equal to 1 by 3. So, 2 pi divided by 1 by 3. So, this 3 goes to numerator and will come 6 pi. Right? So, amplitude is the maximum distance, only one. Right? And the period is the cycle want to go for 0 to 6 pi. Now, take the table value here. Take the value 0 and 3 pi by 2. Next 3 pi. Another one 9 pi by 2. Finally 6 pi. So, take the values of x and substitute to given function. Then this is nothing but y. Okay. Whenever we are applying 0 here, sin 1 by 3 into 0 is nothing but 0. And applying for 3 pi by 2 here, we are getting sin of 1 by 3 into 3 pi by 2. So 3 will be cancelled. So sin pi by 2, that will be 1. And here instead of x we are substituting 3 pi, so 3 will be cancelled. So sin pi is nothing but 0. And after that 1 by 3, instead of x we are assigning 9 pi by 2. So 1 is 3, 3 is 9, so will be cancelled. We get sin 3 pi by 2. Sin 3 pi by 2 is nothing but minus 1. And we are giving x for 6 pi. So 3 and 6 will be cancelled. Sin 2 pi. Sin 2 pi is nothing but 0. Okay. Now we want to draw the graph of sin of 1 by 3x. So this is y-axis and this is x-axis. We want to start from 0 to 6 pi. So take here 0 and mention that in center point this is 3 pi and this one is 6 pi. In between 0 to 3 pi is nothing but 3 pi by 2 and 3 pi to 6 pi midpoint, that is nothing but 9 pi by 2. Okay, so here we are applying 0, the point 0, 0 here. Next we are taking 3 pi by 2, we are getting 1. If I are taking 3 pi, the x value x is equal to 3 pi means y value 0. If I are taking x value 9 pi by 2 means y value minus 1. So take the value here minus 1. And if we are taking x as a 6 pi, the y value is 0. Now I want to draw the graph. This is complete a cycle. This is one cycle. This is required graph of the function y is equal to sin 1 by 3x. Thank you. This is exercise 4.1, question number 4. Find the value of sin inverse of sin of 2 by 3. So, we know that the formula here in properties of sin inverse of function, sin inverse of sin x is equal to x if x belongs to minus pi by 2 plus pi by 2. Here, 2 pi by 3 is given. 2 pi by 3 not belongs to minus within the interval of minus pi by 2 plus pi by 2. Hence, sin inverse of sin of 2 pi by 3, we can write like this. Sin inverse of sin of 2 pi by 3, I am going to write pi minus pi by 3. So, taking cross multiple 3 pi minus pi, 2 pi by 3. Now, sin inverse of pi minus pi by 3 is nothing but pi by 3. because sine 180 minus theta, which is equal to sine theta. Instead of 180, we can write sine pi minus theta also. So sine pi minus theta is nothing but sine theta. Next is, now according to the formula, sine inverse of sine x, which is equal to x. So sine inverse of sine, here this pi by 3 belongs to, that is equal to pi by 3, since this pi by 3 belongs to minus pi by 2 to plus pi by 2. It is the interval. So the answer is sine inverse of sine of 2 pi by 3, which is equal to pi by 3. This is exercise 4.1 question number 4. The second one, sine inverse of sine of pi by 4. So we know that result, sine inverse of sine of x, which is equal to x, if x belongs to in the interval of minus pi by 2 to plus pi by 2. But here pi by 4 not belongs to in the interval of minus pi by 2 plus pi by 2. Right? Now I can write sine inverse of sine of 5 pi by 4 like this. Sine inverse of sine of 5 plus pi by 4. So sine of pi plus pi by 4 is nothing but you are taking cross multiple 4 pi plus 5 by 4. This is nothing but 5 pi by 4. But sine inverse of sine of pi plus pi by 4 is nothing but minus sine pi by 4. Right? Because you know everyone, sine of 180 plus theta is nothing but minus sine theta. But minus sine theta we can write sine of minus theta also. So I can write like this, sine inverse of sine of minus pi by 4. Right? Now this minus pi by 4 belongs to the interval of minus pi by 2 plus pi by 2. The closed interval. Right? This sine inverse, according to the concept, sine inverse of sine of x is equal to x. Because this x belongs to minus pi by 2 to plus pi by 2. Here sine inverse of sine of minus pi by 4. So I took minus pi by 4 only because this minus pi by 4 belongs to minus pi by 2 plus pi by 2. That's all. Alright students, this is exercise 4.1, question number 5. For what value of x does sin x is equal to sin inverse of x? For what value of x, substituting the value of x, we will get both are equal. Let us assume the function going to write like this: y is equal to sin x, and another one y is equal to sin inverse x. But in graph, we can draw sin x to cos x. You see, this is plus pi by 2, and this one is minus pi by 2, and this is plus 1, and this one is minus 1. Here, the curve will goes like this. This is for the graph y is equal to sin x, and this one y is equal to sin inverse of x. So the both curve meets at only one point. This is nothing but what? Origin. Okay. So in clearly sin x and sin inverse of x meets at only one point such that x is equal to 0. So for x is equal to 0, sin x which is equal to sin inverse of x. This is a vector question. So now we have to draw the graph of y is equal to sin x, y is equal to sin inverse of x, and we can easily to solve like this. Okay? As this is exercise 4.1, question number 6. Find the domain of the following: f of x is equal to sin inverse of x squared plus 1 divided by 2x. So solution. We know the sin inverse function. Sin inverse from minus 1 to 1 to minus 5 by 2 plus 5 by 2. This is a function. We know very well this is the domain and this is the codomain. So the x square plus 1 divided by 2x is lies from minus 1 to plus 1. Now take it, this one is the left side, this one is the right side as a separate tree. So minus 1 is not equal to x square plus 1 divided by 2x is one part. Another one now, x square plus 1 divided by 2x is not equal to 1 is another part. Now we want to take it on this side, we will get a minus 1 goes to that side will be here 0 and this one will be plus 1. Otherwise add plus 1 on both sides. Here minus 1 plus 1 is 0, here 1 plus x square plus 1 divided by 2x. Okay. Now cross multiply this one, 0 less than or equal to 2x plus x square plus 1 divided by 2x, which is nothing but x plus 1 the whole square divided by 2x. I can write this one. See, x plus 1 the whole square divided by 2x only b. So I can write like this. Okay? And choose another one. Now x square plus 1 divided by 2x, here 1 now. So right, bring 1 to left side. X square plus 1 divided by 2x minus 1 less than or equal to 0. And taking class into this one, x square plus 1 minus 2x divided by 2x less than or equal to 0. So in numerator we get x minus 1 the whole square divided by 2x less than or equal to 0. So this is the other case. Now we are to draw a real line and find out interval. Which interval satisfies this inequality? We studied in 11th standard also, right? So just to draw the interval minus infinity to plus infinity. Look at the numerator. It equal to 0 means we get minus 1. And denominator we put 0 means 0. But 0 is not valid because x is equal to x not equal to 0. Because if you are assigning x is equal to 0, it will be infinity. Does it exist? You know. But we want to find the limit. So you want to assign 0. Right? So denominator 0 and numerator you want to assign numerator equal to 0. Numerator equal to 0 means x plus 1 equal to 0. X plus 1 is equal to 0 means x is equal to minus 1. So if you are taking x is equal to minus 1. Next, see the another concept x minus 1. So x minus 1 equal to 0. So we are getting x is equal to 1. Right? Now x is equal to 1. Now we have that see the intervals are there and choose any number in between minus infinity to minus 1, minus 1 to 0, 0 to 1 and 1 to infinity. Check if x plus 1 the whole square by 2x greater than or equal to 0 or not. Just pick out this one, minus infinity, minus 1 in this interval. Okay, just draw a table here. This table is not necessary, but for understanding purpose, we have to obtain. So this is interval, and this one is x plus 1, the whole square divided by 2x, and this one is x minus 1 the whole square divided by 2x. Okay. Now we are simultaneously checking both concepts, right? Now the interval minus infinity to minus 1, took any number, so I choose minus 5, but this value want to be greater than or equal to 0 and this value want to be less than 0. That means I simply say it is a positive and it is negative. That's all. Okay. Now took this interval minus infinity minus 1 and take minus 5. You are substituting here minus 5 plus 1, it will be positive. Minus 5 plus 1 the whole square divided by, what about denominator? 2 into minus 5, right? 2 into minus 5. So in numerator plus, denominator minus, but the overall value minus, right? Now check here, here also minus. Okay, next, if you are taking 1 to 0, just to take 1 by 2. If you are taking 1 by 2, here positive. We are taking 1 by 2, here positive. and here also positive, right? Next 0 to 1. 0 to 1 tends to 1 to infinity. Now 0 to 1 take this is minus half. Sorry, I want to go for minus half, 0 to minus half, we are taking minus half, numerator plus, denominator minus, so it is a minus. Here, numerator plus, denominator minus, so it is also minus. Now 0 to 1, we are taking plus half here, so plus half means both are plus. Here, both also plus. Now 1 to infinity, take plus 5. So I am taking 5 means I substitute here plus, but here there are also plus. Now I want to check the first interval value must be positive, the second interval value want to be negative. You see, first interval value positive, negative, so not applicable. Next, here positive you need. Here negative okay, but here positive, so not applicable. Here 0, 1, here positive, here okay, but here want to be negative, so this also not possible. Now taking 1, infinity in between value, this is positive, okay, but this time this interval want to be negative, but here positive. So these intervals are not applicable. Just took the value only one, that is minus 1 only, take only minus 1. Now, if I take minus 1 plus 1, 0. So, if I take 0, it's not a problem, not an issue. If I taking minus 1, here minus 2 whole square, here also minus 1. So, it will become negative. So, it will be correct. If you are taking plus 1 only, okay, you are taking plus 1 only. So, 1 means you are taking here positive, not an issue, but here 0. So, we can fix minus 1 and plus 1. So the domain of sine inverse of x square plus 1 divided by 2x is minus 1 to plus 1. We have to write separate. Okay, no problem. So minus 1 to plus 1. That's it. Hi students, this is exercise 4.1 6th question, second domain. Find the domain of the following. Now we want to find the domain. So we want to consider the only for x values, right? We know very well sine inverse functions is defined from minus 1 to 1 to minus 5 by 2 to plus 5 by 2. So this is entire domain of sine inverse function. Now we want to check whether this 2x minus 1 belongs to 1 to minus 1. Now we want to check whether it for what values of x it must be in minus 1 to plus 1. Right? Okay. So now add 1 on both sides because this minus 1 want to remove, so add 1 on entire term. You see? 1 plus 1. So minus 1 plus 1 will be 0. So this is nothing but minus 1 plus 1 will be cancelled. So 2x is not equal to 2. Now you divide by 2, we get 0 by 2 is not equal to 2x divided by 2 is not equal to 2 divided by 2. 0 by 2 is nothing but 0 and is not equal to 2 will be cancelled. X here is not equal to 1. Now x from 0 to 1, so we can write in closed bracket like this. So x belongs to 0, 1 is required domain of this question. This is exercise 4.1 question number 7. Find the value of sine inverse of sine 5 by 9 cos 5 by 9 plus cos 5 by 9 into sine 5 by 9. So, we know very well the formula sine of a plus b. Sine of a plus b is nothing but sine a cos b plus cos a sine b. Therefore, sine of 5 by 9 into cos of 5 by 9 plus cos 5 by 9 into sin 5 by 9, which is equal to sine of 5 pi by 9 plus 5 by 9. which is equal to sine of denominator is the same, add a numerator 6 pi divided by 9. This is nothing but we cancelling by third order, so we can get 2 pi by 3. Okay, now you see the question. Therefore, sine inverse of sine of 5 by 9 into cos 5 by 9 plus cos 5 by 9 into sine 5 by 9, which is equal to sine inverse of sine of 2 by 9. Right? So, we know very well sine inverse of sine x, which is equal to x if x belongs to minus pi by 2 plus pi by 2. This is the concept here, but 2 pi by 3 not belongs to in the interval of minus pi by 2 plus pi by 2. What do we know? So we have to alternate that this value like this. Sine inverse of sine of 2 pi by 3, we can write pi minus pi by 3. So cancel, we get 3 pi minus pi, we get 2 pi by 2, right? Okay, now sine of 180 minus theta, sine theta. So sine inverse of sine of pi by 3, which is equal to pi by 3. Hence, sine inverse of sine of 5 by 29 cos pi by 9 plus cos 5 by 9 sin pi by 9, which is equal to